Boom, we're rolling. How you doing, Rob?
Doing great, Travis. How you holding out in this COVID world?
Oh, it's fine. It's all right. I can't complain.
Where are you located?
I'm in Long Beach, by LA.
Long Beach,
So
California. So you're surrounded by people. Unlike my background, which is a bit fake, this is an aspirational background. I want to be on the beach. I'm actually in a on a farm in central Alberta, outside of Olds, Alberta, north of Calgary. So I'm kind of we measure social distancing here in our country, Travis, by miles, not feet.
so you haven't seen a person in years there.
Yeah, that's right. Yeah.
Cool, man. Well, I'm excited to talk to you, Rob, because you make a good point. Like, kind of reading, doing my research on this stuff. You made a good point that is totally true with me, which is that I have no idea how, or have put very little thought into how the food that I eat even gets to my face.
Right.
You know,
Right.
it just shows up, and I just take it for granted. There's tons of it; it's never an issue. But this is what it is potentially a big issue.
Yeah, it's. I think that COVID has brought COVID and a COVID world. Social distancing has brought the importance of food supply to the forefront of people. And I mean, people are stocking up on toilet paper and people stocking up on, well, that's a good example. Really? Stocking up on toilet paper?
Right? Yeah.
Maybe. And they began to realize after they got all the toilet paper home enough for 3 years, they began to realize that maybe the real thing we should be concerned about is, will we have enough food on the shelves of the grocery store? And where does that come from? And how's it going to get here? And people don't think about the implications of a COVID situation on farming, on farm supply businesses, on transportation, distribution, processing of food. And ultimately, they just think about the grocery store. They are inconvenienced because they need to go, according to the arrows, up and down the aisleways of a grocery store. They have to wait outside before admission, or they have to keep distance as they wait for the checkout counter, not thinking about all the steps that are in between there and that basket of groceries that you're getting ready to pay for.
Yeah. So are we heading towards a disaster type of stuff because of COVID?
No, no,
Okay.
we're not. The food supply is extremely resilient, and I think this is one of the things that people, need to understand is that we have we have immense distribution, we have immense systems in place to ensure that our food arrives cheaply, safely, dependably to the consumer. Now, with all of that being said, there are parts of the food system that are of concern to me, and that is the area of fresh produce and perhaps fruits and vegetables in particular. And you live in California, so you're not far away from a lot of those production areas. And the concern I have really is surrounds the surrounds the ability of farmers to attract enough workers. And a lot of these are foreign workers. In Canada, we depend on a lot of foreign workers, Jamaican, Mexican workers, to come in to harvest the crops and work with those farmers. Um, Canadians or Americans listening to this say, well, just hire Americans, just hire Canadians to go pick those vegetables. I guarantee you, at a 90-degree day, you'd last about all 5 minutes.
Yeah.
So these people are
I don't want to
resilient.
do it.
And
Yeah.
secondly, is you don't have a clue on how to do this stuff. I mean,
No.
these people are trained year after year. They show up at the farm and they work hard. They get paid fairly, and they pick the fruits, vegetables, package them, whatever, and then they go back home after the harvest season is done, and they know what to do, and they've been doing it for year after year. So, a typical American or Canadian wouldn't have a clue what to do.
Mm-hmm.
Go up on the farm. In fact, it would create more work for the farmer, not less, because he would have to train you on what the heck to do, and you haven't got a clue. And
Right.
so, picking a tomato at the right ripeness, plucking off the right bunch of grapes at the right time. Those are kind of an art form. You have to be taught.
Mm-hmm. Okay. So I did not realize that at all, that was kind of the issue was with labor and having enough people to do all this.
Huge. That and the other area, Travis, that's of concern is is processing facilities. So think a meat packing plant where the meat is harvested from the hog or chicken or cow. You do have a large number of people working together in a processing facility. Same thing with milk. You've got a large number of people working there in the processing facility. And keep in mind that those facilities are there because they are regulated by the USDA, or in Canada by the CFIA, to ensure that the food arrives safely. So, when you're butchering a cow or something, there's all kinds of contamination opportunities in that system. And our plants today are designed to minimize the transmission of E. coli or salmonella. So you don't hear much about that because our system is resilient in that way. But it also puts a lot of people together because of economies of scale into one area. And so that, to me, those are the real big concerns that I have. Would be workers on farm, adequate workers on farm to harvest and to work under high value added foods like fruits and vegetables. The processing plants are a vulnerability. Generally, transportation and distribution isn't a big deal. The other area that's a bit of a pinch point is farmers themselves. When you consider that a lot of our farms out here in Canada are 5, 10, 15, 30,000 acres and may have between 5 and 15 employees, those employees at springtime and harvest are essential to getting the crop in and off the field in a short time frame. So we want to make sure that the workers and the farm itself is safe from disease transmission. So the incubation of the farm employees during these peak seasons is also something that our farmers have had to manage and deal with.
This is interesting because I mean, it's not like I'm following agricultural news, meticulously every day, but from what I've always heard is that the things are getting more automated and things like that. So I wouldn't have thought that this would be a concern.
Well, they are getting more automated. I mean, it wasn't that long ago a farmer fed 20 people. Today, one farmer's feeding 200 people. And so that economies of scale, that efficiency is happening through mechanization and through access to sensor technology and data integration, remote sensing technology. That's happening through integration of GIS, or geographic information systems, and GPS and the equipment. But when you still consider that a tractor and a planter, or a tractor and an air seeder, that complement of equipment is probably worth $1.5 million, that a combine is worth $750,000 to $1 million. You can't put untrained individuals on that equipment. So yes, farmers are able to farm vastly bigger tracts of land with many few people. But these farms are also, due to economies of scale, bigger. And I talk about that in my book, Food 5.0, where we talk about how to feed the future. And I talk about farmers of consequence. And, if I say the word agriculture or the word farm, Travis, and what pops into your mind is a red barn, or a round fendered pickup truck, or farmers with bib overalls and a straw hanging out of their mouth. If that's your picture of farming, then you're watching the History Channel. And that has zero relevance to farming today. It may play a role in farm tourism or agritourism or small nichemanship, but that does not represent how we get 80+% of the food to our farm through what I call farmers of consequence. And really what I'm talking about here is farms of scale, farms of consequence. And I'm not talking about factory farms and the industrialization of agriculture. I'm talking here about farm families who have incorporated their business. Typically, they're somewhere in the neighborhood of 3 to 5 generations long, and they've incorporated their business. And 97, 98% of all farms today in North America, being Canada and the United States, are family farms. Vast majority of the big ones today are incorporated because that's just smart business.
Okay. No, I get this. And then, so you mentioned your book, like a major concern and or something you talk about in your book is just having enough food for everybody, right?
Yeah, I mean the question around food production and abundance of food is within our grasp as humanity. We have still about 800 to a billion people going to bed in a not a starvation but a food deprived mode. Some of those are actually in America, believe it or not.
Wow.
And so that has a lot to do with distribution of food from the standpoint of us. And you know, you could argue demographics, whether our 7.8 billion is going to reach 9.5 or 10 billion by 2050. It's probably not that big of an argument as to where it ends up, but it'll probably end up at 9. uh, Demographically speaking, many areas of the world are actually going down in terms of population, not up. But places like Nigeria, India still are increasing. I have shares in a farming operation in Uganda. That's another area that's exploding. Average age in Nigeria or Uganda is like 16 to 17 years old. So
Wow.
those young people are all going to have children, and so it's you know, it's going to explode in population in certain areas. But
Hmm.
our ability to feed the future really is predicated upon two things. I think number one is technology integration in agriculture and the implementation of science in agriculture, because they're not making more land. So we have to feed the people off the land base that we have, or a smaller land base. And the second thing is the distribution. In other words, can we get food closer to the point of consumption faster? Can we grow it to the point of consumption quicker? Those are the things that go through my brain.
S- Okay, so the two issues were distribution and then
and
kind
then
of
and then production, the integration of science to allow agriculture to produce food. So I mean, people, you know, they're quite hung up on the organic label. Well, you buy it if you want to. I don't personally, but if you did convert all farming to Uganda or to organic farming, if you did convert all farming to organic, then there's something called a yield drag. Organic farming simply doesn't produce as much food as conventional farming that utilizes the science of crop protection and fertilizer, etc. So where are you going to find where are you going to find another California to cultivate? Because that's the yield drag you're talking about. People are upset because scrubland next to the Amazon is getting knocked down. What's going to happen when we have to find another California to till? And where are you going to find that from? And what marginal land are you going to cultivate to make that happen? So when people look at agriculture and food production and they come up with very simplistic answers, then I look at them and say, you haven't got a clue, because agriculture is a very nuanced industry with all sorts of complexities that are regionally based, and there are no silver bullets. No one answer fits all parts of agriculture on the planet. No way.
hmm okay, so we just sort of need to, because like you know, me being a consumer, I hear organic and I go, well, hell yeah, let's buy that. It's better. That's what I've been told. But is that not necessarily the case?
Well, I'll turn the interview for a second. So what does organic mean to you?
I mean, I guess not using pesticides, not using stuff that's bad for me, growing it is where my
Fair
knowledge
enough.
goes.
Fair enough. Okay. So if a farmer didn't have to use pesticides, wouldn't all farmers not use pesticides? Because it costs money. Why would they use pesticides if they didn't have to?
Uh, uh, Good question, I guess. Good
Right.
point.
So you're growing organic spinach and you don't use pesticides? How do
So,
you keep
okay,
the how do you keep the bugs and the diseases off your organic spinach?
I have no idea.
Well, if you could keep it off by not using pesticides, wouldn't all farmers just not use pesticides?
Right. You would think.
So how do they control the pests? How do they control the insects and the diseases on organic spinach?
I have no idea.
Well, they use organic pesticides.
Oh, what does that mean?
Well, they use organic pesticides, like nicotine is an organic pesticide. Well, it's not an organic pesticide, it's an example. Organic pesticides would include things like pyrethrum. Pyrethroid is the synthetic mirror to pyrethrum. Pyrethrum is an organic insecticide. It comes from chrysanthemums. So they pluck the leaves off the chrysanthemums, they crush it, and that yields an insecticide called pyrethrum. Because it's derived from an organic source, organic farmers can spray that organic insecticide on the organic crop and still call it organic because it doesn't use synthetic pyrethroid. Now, paradoxically, pyrethroid, that is the synthetic derivative or cousin to pyrethrum, the organic, is safer for humans than pyrethrum. So the organic form of pyrethrum that the organic farmer is using has 2 extra esters in it, which is more toxic to the workers on the farm. And pyrethrum is more toxic to the bees and the butterflies than pyrethroid is. So therefore, they're growing their organic spinach and they're controlling the diseases and insects. Otherwise, why wouldn't all farms just not use pesticides? Because you said you buy organic because it means no pesticides. It's not true. You have to control insects and diseases. So diseases like ascochyta, for example, which is a mold, on organic grapes. Well, what do they use? They use elemental sulfur, and they use millions of pounds of it. Organic farmers would utilize something called Bordeaux mixture. And Bordeaux mixture is a combination of copper sulfate, which is quite toxic, and slaked lime. So they mix together copper sulfate and lime into a mixture called Bordeaux mixture, and they spray that organic mixture on their organic crops. Well, this was first used and discovered on the roads leading to Paris, where the grape growers sprayed this mixture on the grapes to stop the pedestrians along the roadway from eating their grapes, because people walking to Paris would just eat the grapes of the farmers. So they made up this Bordeaux mixture of copper sulfate and slaked lime and sprayed it on the grapes. And it was a human side, first of all, because it prevented humans from eating the grapes. But then farmers discovered that it was a fungicide. It had fungicidal properties, so it could control white mold and ascochyta in grapes. And it's the number one, or one of the biggest fungicides used in organic production is Bordeaux mixture. It's been around forever. Chrysanthemums or pyrethrum goes back to ancient China. So again, when you say somebody buys organic because it means that they don't use pesticides, then I'd say, why wouldn't all farmers go organic? Because they have to control the bugs and insects and diseases and weeds that come onto a farm. And another question would be, well, how does an organic farmer control weeds on his farm? Because a conventional farmer will use something called a herbicide that we'll use and spray on literally grams per acre of a very specific compound designed to control the weeds in the crop. So I would ask you, how does a organic farmer control weeds?
They must use something.
They do. They till the land. So they use a lot of tillage. So where a conventional farmer that practices no-till using genetically engineered crops would use 1 or 2 sprays of a herbicide to control the weeds, organic farmers would have to, by the very fact, utilize things like mulches and plastic covers, which is great, but they would also have to rely on tillage. And if you care about the quality of the soil and the groundwater, and if you give a shit about climate change, then tilling the land is really not the way to go, because every time you till the soil, you release carbon dioxide into the air by degrading the organic matter, which reduces the water holding capacity. So tillage is not a sustainable manner for long-term agriculture sustainability. You want to reduce tillage, you don't want to increase it. So if we all went organic, we'd have to rely on much more tillage, and tillage degrades soil. So that again is an antagonistic type of a thought process. So what's more important? Is it more important to keep the soil healthy on our planet Earth, to reduce tillage, to reduce greenhouse gases, to increase water holding capacity, to increase organic matter? Or is it more important to till the soil and call it organic? Like, what's more important?
Right. Man, okay, this is interesting. Like you digging into this, I have like a million questions. But so it's even if it's organic produce or something, they're still using pesticides, but they're using organic pesticides, which may in fact be inferior to non-organic pesticides.
Right. So another example would be Bacillus thuringiensis. Its acronym is BT. Bacillus thuringiensis is a series of proteins, they're bacteria, and you spray these on the crop and it controls Lepidoptera, which are like worm insects in crops like corn, soybeans, and cotton. So you could spray Bacillus thuringiensis, which is an organic insecticide. The problem with it is you have to spray it repeatedly on the crop. So it's not that strong by itself, and it doesn't have a long leaf life, so you're spraying it repeatedly on the crop. Coincidentally, Travis, the BT, the Bacillus thuringiensis, is the same protein the scientists have isolated and clipped out of that organic compound and put into crops like corn, soybean, and cotton. It's called GMO BT, Bacillus thuringiensis, corn, soybean, and cotton. And it's one of the untold success stories of GMOs, is that we don't have to spray insecticide on corn, cotton, and soybeans anymore because we have an organic BT protein that's been put into the crop to create its own resistance. So we don't use organophosphates or carbamates anymore, indiscriminate insecticides that do kill bees and butterflies indiscriminately. Instead, we've got BT, corn, cotton, soybean, squash, eggplant, and those crops now develop their own insect resistance because the protein is inside of them. But the protein was in fact derived from an organic insecticide. Was
Wow,
that a mind twist?
that's super cool. That's awesome.
It's very cool.
Man, okay. And then so now my question is there are there certain I guess inorganic pesticides that are are bad for human consumption or have had negative effects for humans? Like are there instances of that?
Well, yeah, the answer is yes. I mean, if you ingest too much elemental sulfur, it can make you ill. If you ingest any number of organic insecticide compounds, could have detrimental effects, but no more so than synthetic pesticides would be. And the key, whether it's organic or conventional, the key is wash your damn fruits and vegetables. Because
Okay.
if you wash your food, you're going to wash out 99.99% of anything that's on the food. So just wash your tomatoes, just wash your cucumbers, wash your potatoes, wash your squash, wash your lettuce. Once you do that, yeah, these foods are safe. You got to remember that the amounts that we're using, be it organic or conventional, are parts per million, in some cases parts per billion. So the risk level to a human being is very, very negligible. So just wash your food; it'll be safe.
Okay. So that's good to know. So it's it's necessary to use pesticides and insecticides and everything like that to grow these properly, but we can get rid of them essentially by washing our food. So what's the proper way to wash fruits and vegetables?
Well, just put them in a bowl and run them under the sink and wash them off. Like lettuce, you can just rinse off. Again, this is an area that probably is best best answered by a food dietitian. And I much rather would listen to dietitians than nutritionalists from a standpoint of their education and stuff. But a dietitian would be a good person to talk to. The other thing you just mentioned, I thought I should jump on is, these crops that farmers are growing, potatoes, for example, you could have $3,500 to $4,000 an acre into potatoes, $35,000 to $4,000 per acre. Multiply that by 1,000 acres. That gives you the gravity of the amount of money that is at risk. And so if Colorado potato beetle comes in and starts ravaging the potato crop, it's not like you can just go out there and pluck the Colorado potato beetles nicely off 1,000 acres of potatoes. That dog don't hunt.
Yeah.
And if you got 3,500 times 1,000 acres worth of crop out on the ground, and Colorado potato beetle comes along, you've got to protect your crop. And that's why the crop protection industry exists. And anybody who tells you that we could just grow crops without insecticide, fungicide, or herbicide is dreaming in Technicolor, because that ain't going to feed the planet.
Okay. No, that's good to know, because honestly, I would never have understood that, but it's a good fundamental thing to know, I feel like. So thank you for kind of explaining that and going through all that. So do you think that there's just kind of the conception that organic is better and things like that is just kind of a fear that consumers have?
Travis, it's marketing. Marketing.
Okay.
Every time you pick up, here, I'll give you an example here. All right, this is one of my favorite. You ready for this?
Hit me.
Right. This is Himalayan rock salt. Okay.
Oh, sure.
Right? Good, eh?
Oh, yeah.
Himalayan rock salt has been in the Himalayan mountains for millions of years. Best before date on it, July next year. You got to, first of all, that's silly. But this Himalayan rock salt is non-GMO. Holy cow. Non-GMO Himalayan rock salt. First of all, it's salt. There's no biology in salt. So how do you have a genetically modified salt? You don't. There's no such thing as a genetically modified salt. But if I slap this butterfly on this salt and it's sitting next to another Himalayan salt without the butterfly, I can charge you another $1.29 because this is non-GMO Himalayan rock salt.
Sure.
Then I got you, man. And that butterfly is money in my jeans, money out of your jeans and money in my jeans. It's the same thing as you buying this butterfly on Catelli pasta, or you buying this butterfly on Hunt's tomato, or you buying this butterfly on spinach, or you buying this butterfly on any number of products out there. There is no genetically modified spinach. There is no genetically modified durum wheat. There are no genetically modified tomatoes on the marketplace. It is marketing, it's deception, and is designed to pull money out of your pocket based on fear that if it was GMO Himalayan rock salt, it's somehow bad for you. Well, that is nonsense.
Okay.
Marketing.
Wow. And so I guess I'm just trying to think of how this would originate. It must have just come up as these guys are thinking of marketing ways, and this became a way for them to differentiate their product, these identical salts almost, and they can differentiate themselves and charge more.
Right. I want to build my own label for watermelons. I'm going to put boneless watermelons on these labels because everybody should have boneless watermelons. Like, why would you want watermelons with bones in them? Mine are boneless.
Right.
All watermelon are boneless, but yeah. So, non-GMO, gluten-free. Well, gluten is interesting. We should talk about that. But non-GMO seaweed, I've seen that. Like non-GMO maple syrup. Like there are no genetically modified maple trees. There's a handful of crops, maybe 9 crops around the world that are genetically modified right now, and they're the biggest staple crops that we use to feed people. And they're very, very important. And that science is very important for the future of humanity, but it's vilified by these freaking marketers like this Non-GMO Project marketing. I have no use for these people. They are deceptive. They lie to you as a consumer, and they extract dollars. All of the people who put this on there are using that to inflate the price to extract dollars from a consumer that's ignorant. And I didn't mean stupid. I'm just saying ignorant, doesn't know
Right.
This is a lie.
Sure. Well, there's so much to learn. It's hard to be like clearly informed on everything. So you can't blame people, but this is why we're here doing this. So
Why we do what we do. This is why I wrote the book. This is why I have these conversations. This is why I did the TEDx talk, because people just don't know.
Yeah. So can you give me, so GMO is genetically modified organism, is that right?
Now, genetically modified organisms, actually, it's a very poor term because a lot of, well, virtually all of the food that you eat has been modified in some fashion, and so it more precisely refers to the science of genetic engineering, and so that is a more accurate way to describe it. If I asked you, okay, I'll do this, Travis. So I'm going to take a plant. I'm going to take some seeds of a plant, and I'm going to take it to I say laboratory. Some people say laboratory. I'm going to take it to a laboratory, and I'm going to put it in the laboratory, and I'm going to expose those seeds to nuclear radiation. And I'm going to expose those seeds to nuclear radiation, gamma radiation, for 1 day, 1 week, 1 month. And then I'm going to grow them to see what kind of mutations happen. Or I'm going to take those same seeds and I'm going to subject them to carcinogenic chemicals to cause mutations to happen. Would you think that is a GMO?
I guess so.
Yeah, right. That is a process that's known as mutagenesis. It's been around forever. Our grapefruits used to be white in color. Now all the grapefruits are red. How did that happen? That happened by exposing the grapefruit seeds to gamma nuclear radiation and freaking out those seeds in a randomized mutation of the chromosomal complex, resulting in the ruby red grapefruit that I think it was a real red that resulted in the ruby red grapefruit that we all enjoy today. That whole process is not a GMO. That is endorsed by the Organic Association. So the Organic Association endorses or says that the mutation, the random scrambling of genetics through exposure to nuclear radiation or carcinogenic chemicals is okay as a breeding process. But if I take a crop like soybean and inject BT, Bacillus thuringiensis, into the soybean, that's freak of nature, man. And that's that's a GMO. That's bad. Explain to me how, if I flick off, I got another one here. Hold on. This one here is an Arctic apple. So this is a technology where Neil Carter and some of the guys in Okanagan and British Columbia have figured out how to flick off 3 to 4 genes inside of an apple to prevent the apple from prematurely browning. They flick off something called the polyphenolic oxidase reductase enzyme, something like that. Anyway, they flick off 3 or 4 genes in the apple. They didn't introduce anything. They flicked off some genes to prevent the apple from prematurely browning. So they flicked off some genes using genetic engineering or gene editing, and yet you can scramble a crop inside of a lab using nuclear radiation and carcinogenic chemicals and call that organic. And yet the flicking off of 3 genes inside of Arctic apple is somehow the devil because it's a GMO or gene edited. Like, wouldn't you rather have an engineered bridge than a modified bridge, Travis?
Yeah.
Yeah. So what is genetic engineering? Well, genetic engineering is an advancement of the currents that we have today, which is the advancement of binary code, the advancement of computing power and data mining, computer computational power, coupled with genetic code, which is ATCs and Gs. Those are the formative proteins of genes in your chromosomal complex. So really all we have going on right now is the ability to read massively greater strands of genetic code, figuring out where anomalies might be or where we want to make changes and make those changes more precisely than subjecting the seeds to nuclear radiation. And somehow people are freaked about this. And I'll guarantee you that when a vaccine is finally approved for COVID-19, that vaccine will have at the heart of it data management, genomics, and genetic engineering. How could it not?
Yeah.
We don't have 10 or 15 or 20 years in the case of Yukon Gold potatoes, 20 years of breeding using conventional technology to make it happen. We need a cure for COVID right away. And if it's good enough to develop the technology that's going to help to fight COVID for humanity, for crying out loud, don't you think this technology is good enough for farmers to also integrate into the crop breeding processes, to utilize less inputs, to decrease the environmental footprint, or to help grow crops that are more saline resistant or more drought tolerant? Don't you think that that makes sense?
So let me, because I think I'm understanding here, but let me just summarize and you tell me if I'm on the right track here. So you're saying that these seeds, like the grapefruit seeds you said, for
Yeah.
example, they're just sort of randomly
Scramble.
modified, scrambled. But if they were scientifically, modified, and like we went in there
Engineered.
and engineered, this would be
That's a
considered.
GMO.
This is a GMO, but this is still organic.
It's organic.
And this is just
Overtreated.
random, but this
Yeah.
is scientifically, they know why they're doing it and what's going on, I guess.
Yeah, about 3,300 crops on your right hand owe their origins to random scrambling, and they can be grown organically. You can put an organic. You can grow ruby red grapefruit without synthetic pesticide or fertilizer. So you can use organic fertilizer and organic pesticides, and you can grow that ruby red grapefruit and slap a non-GMO sticker on it when it was derived from nuclear radiation mutation in a lab. So tell me how that all works out. Riddle me that, Batman.
Man, so these are just they just feel like arbitrary,
I love
labels
this
that have
interview.
been made.
Your eyes just keep going like I didn't think about that. I didn't know that. That's again why I wrote the book. People have no clue. They don't know.
No idea. I mean, you hear all these labels and stuff, but I really don't even know what the labels mean. I'm just told that they're good or bad, I guess, and that's not even
nonsense.
Yeah.
I go to the grocery store. I watch people trying to make a decision between all these labels, and I just laugh. I love watching people being deceived and dollars pulled out of their pocket by label. I particularly get upset with let's call them single moms who are living on pretty limited income, and are being pressured through social media to buy their kids organic, non-GMO this and stuff like that, when that pricing is typically anywhere from 40 to 600% more than a conventionally labeled product. And there's no difference in the quality or value of the food. And that mom is being pressured into spending more. If she buys that conventional product, she thinks she's hurting her kids somehow. This really pisses me off. That there's no call for that. None.
Mm-hmm. So the term GMO, it's not inherently bad. It's potentially great.
Inherently good.
Yeah.
It's inherently good. Genetically modified crops have resulted in a reduction of soil degradation at farm level. They've resulted in the massive decrease of herbicide utilization. And you'll hear people say, oh yeah, well, Roundup use has gone up like this much. Yeah, but what did Roundup replace? How many herbicides did Roundup replace on the herbicide tolerant crop? When I spray my canola with Roundup, or people always attack Roundup, but they know everything about glyphosate, but they know nothing about glufosinate, which is another cousin. Well, it's not a cousin, a different product. But anyways, when I use those products, those herbicides on my crop, I'm spraying a pop can of product on a football field. And the only reason you see anything coming out of the back end of the sprayer is because you're seeing the water come out of the back end of the sprayer. We're using between 5 and 20 gallons of water per acre to carry a pop can and distribute that over a football field. Roundup is one of the safest products we've ever used in agriculture. It has a LD50, which is called the lethal dose to kill 50% of the rat population, of 5,900. The higher the LD50, the safer the product. And Roundup is safer than aspirin, is safer than, well, the active ingredient in Roundup, glyphosate, is safer than aspirin, safer than salt, safer than caffeine, safer than nicotine by a long shot. Roundup is just slightly less safe than alcohol. And again, I laugh when people put a non-GMO sticker on vodka. Like, for frick's sakes, there's no genetic material left in vodka. It's all alcohol, and it's a known carcinogen. So.
Okay, Rob. Well, I know you need to get going, but should we just kind of wrap it up with like people? I feel like the message of this has been great, but it should be that folks listening shouldn't be afraid of technology being implemented into their food.
If we don't, we're doomed.
Yeah.
Agriculture, the integration of agriculture science is what's going to keep our planet fed and healthy. And as long as we have people on the planet, agriculture must be infinitely sustainable. And Travis, we should schedule another one, because I'd like to have a conversation about sharing with you the technology. So we've just been dealing with what I call the soft technology of agriculture, which is the bio side. But I'd like to deal with the digital and tech side in another conversation sometime, which takes you into the world of remote sensing, data management, satellites, GPS, robotics, all of that, artificial intelligence and machine learning as we're using it on the farm. I think that'd be a fascinating conversation. But this one here was really cool. I love the fact that you picked up my book. And if people want to get a hold of me, they can Google me. I have my own website, my own domain, robertsaik.com. The book is on Amazon. Got a TEDx talk that I gave a while ago that's called Will Agriculture Be Allowed to Feed 9 Billion People? And numerous podcasts and writings, and just working on turning the book into an Audible right now as well. So just working on
nice.
that. Yeah.
Very cool.
So anyway, it's I don't know how you connected with me. Like you said, you found me through the book, but Travis, I applaud you. We need more young people. And I have a son, Nick, he's 30. Nick Saik runs a media outlet called No Ideas Media, KNOW, No Ideas Media. And if you go to No Ideas on YouTube, you'll find over 120 videos that deal with agricultural science and education. Everything from genetic engineering as explained by Lego. So,
oh, wow.
And right over to glyphosate and Roundup in your Cheerios. So we've covered all of those things at No Ideas Media.
Okay, sweet. No Ideas Media.
He'd be a great interview for you sometime too.
Okay,
I am biased. I am biased. He's got hair like you. You got big hair like you.
Gotta have that big hair.
Big hair.
Well, this was great, Rob. Yeah, I'll have links in the description for folks listening to click on all that stuff to your book and the TEDx talk website, noideas.com, so people can check that out. But yeah, I appreciate you coming on. Thank you so much.
This was really enjoyable. I really enjoyed it, and looking forward to the next one.
Yeah, heck yeah, let's do it. Have a good one, Rob. Thank you.
Bye.
Bye.